As an introduction to Unit 5, where we're going to be taking a look at the application of differential calculus, we just need to take a look at some definitions. If I want to know the gradient, I need to know that that is the gradient of a line. I could have had an increasing gradient, a decreasing gradient, or I could have had a horizontal line, which is a stationary gradient. When I have an increasing gradient, I know that the derivative, which is the gradient of my tangent at that point, would have had a positive value. A decreasing gradient means that my derivative is going to be less than 0, and a stationary gradient means that the derivative is in fact equal to 0. From this stationary gradient, I can now say that the turning point is in fact going to be a stationary point, and I know this because the gradient of the tangent at this point is going to be a horizontal line. There are two nice tests that we can apply to find out if our turning point, which we now can call our stationary point, is going to be a local minimum point or a local maximum point. That is, if I zoomed in onto that point, would it have turned so that it looked something like this? Or would it have turned so that it went up? If I wanted to assess where the point was at a locally low point on my graph or a locally high point on my graph, I could follow the following procedure. I would find the turning point, and that would have been found using the derivative and making that equal to 0 and solving for x. Then I would have found the expression for the second derivative. I would have taken the x value from my first derivative, put it into my second derivative, and if I had found the answer to be positive, I would have had a local minimum. If I found the answer to be negative, I would have had a local maximum. At the moment, this sounds like a lot of words, but we're going to be putting this into practice. And as we do that, you're going to find it all becomes a lot clearer. Next, I also need to know, what is a point of inflection? Well, you can see that I have got a curve over here. I've shown you two turning points. A is a local maximum turning point, and B is a local minimum turning point. But somewhere between A and B, my graph changed concavity. Concavity is the shape of the curve. You can see coming up towards A, my graph is concave down. And then somewhere between A and B, my graph changed so that it went concave up. Now, if you can't remember concave up or concave down, it's best for you just to remember up like a cup. So there's a point somewhere between A and B where my concavity changed from concave down to concave up. And if this point was, say, here, I would call that point the point of inflection. At the point of inflection, my second derivative is in fact equal to 0. On the left of my point of concavity, as my graph was concave down, my second derivative would have been less than 0. For concave up, my second derivative must be greater than 0. There are two ways that I can test that the point that I've shown here with the red cross is in fact the point of inflection. Just before it and just after it, can you see that you've got the same gradient? My gradient goes increasing, let's do this in blue, increasing, then it goes decreasing, and then it goes increasing again. So if I look for an x value just to the left and just to the right of my point of concavity, my gradient must be the same. Just between A and my point of inflection, my gradient is decreasing. Just after my point of inflection and before B, my gradient is still decreasing. So it looks like it could definitely be a point of inflection. The other thing that you would find to find your point of inflection is that your concavity, as I've already pointed out, must change. On the left, my point of concavity gives me a negative. On the right of the point of inflection, the concavity gives me a positive answer. Let's see this summarized on the next page. So the first test that I've got tests the gradient, in other words, the first derivative, and close to this point, the x value, I must have the same gradient on both sides. The second test, we said, tested the concavity, and this means that on the one side, my concavity must be concave down, and on the other side, concave up.